Hey, it's Max92, and welcome to Shenzhen IO. This is a game that I bought because it has a Solitaire game in it that apparently is really good, but it's also just like a weird electrical engineering game thing, and I want to play it. I have a stupid setup right now, so hopefully any of this is working, but I have the camera set up with this is a manual that the game has you kind of put together. So I've got that, and hopefully the game will pick back up here. I've got it set up like this so that when I look at the thing, you can see it when I'm messing around in that. But for now, before we do any of that, I'm gonna get here. So I don't know what I'm doing. I haven't really started this game. I think this opens the PDF version of that document, so I don't need that. I think I just have to hit this button. Alright. Dear new employee, thank you for joining the Shenzhen Longteng Electronics Company Limited. We aim to become a world-leading company in the electronics industry and a respected brand with products in homes, offices, and public spaces across the world. Longteng Electronics was founded on the following principles. Diligence, this means both diligence in your work and diligence in your life. When you encounter a problem, do not give up. Even if you are not talented, by working at it every day, little by little, you can achieve the goal. 2. Connections. The process of creating electronics is the process of creating connections between different components. In the same way, we do business by making connections with other people. Therefore, it is important to always be making connections in your work. Salubriousness. That's not a word I'm familiar with. An unhealthy mind creates an inefficient design. An unhealthy body builds a defective product. Follow correct eating, correct behavior, and correct thinking in order to maximize your potential. Please keep these principles in mind as you contribute to our efforts. Wang Yangheng, CEO, Shenzhen Longteng Electronics Co. Limited. I'm not very, I don't come across, I don't know how to pronounce Chinese very well. So I probably am pronouncing a lot of these very wrong. So in the document here, let me switch over. In the document here, I don't know if these are the emails, but these are some of the story documents here. And I'm assuming they might line up with some of the documents over here in game. So let's scroll through these emails here. Carl Teskey. Fresh meat. Just kidding. Welcome to southern China. It's alright, I suppose, except for the heat, smog, and lack of decent cheese here in Shenzhen. Still far better than any engineering gig I can get back home in the UK, though. I'm assuming you ended up here for similar reasons? Carl. That was not any sort of English voice. But whatever, we'll move on. So we got Joe. Yo! So I heard you're our newest ace engineer who's gonna kick ass and take names, am I right? You've probably heard all about me already, but I'm the product guy who loves to find amazing opportunities and make deals happen. Let's do this! Joe Haito, product manager. Okay. So Wu Lily. Greetings and welcome to the team. As you've already been made aware, we're on a major international expansion effort, and we are very eager to see you bring your skills and expertise to our company. Lily Wu, Vice President of Product, Longteng Co. Limited. David. I can't read Chinese, so I'm not going to try. My name is David, or in Chinese, and I was brought on to help Longteng with its international push, though I've only recently moved here from San Francisco, where I should point out, there is a very vibrant Chinatown. I am really loving it so far. It is truly fascinating to see a culture at once so ancient and so modern from up close. I'm sure we will be working together to create many successful products. Still can't read that. David P. Solomon, International Product Manager, Shenzhen Longteng Electronics Co. Limited. And finally we have here, hello, my name is Ji Zhang. I don't know how to pronounce that. Zhang. I'm the chief staff engineer, your boss. I have not managed many foreign workers before, so please understand if I make a mistake here or there. Anyhow, I will send you your first job shortly. Jie is what I'm assuming. And here's Carl telling me to read the manual. The manual is right here. This is the manual. So if the game tells me to read the manual, this is what it's talking about. I know you're so good at engineering, systems, and life in general that you haven't needed a manual in ages, right? Well, trust me on this one. You really want to read the manual here. Even better if you keep it handy as you work. Right there. Don't be like the non-manual using person who just quit just before you started and whose name shall be never uttered again. Carl. Okay, so we have our first job here. But before we get to this, I'm going to look at these emails here. Let's pull that up. So this is Margie Fish. Good morning, just a quick update for you today. First off, I've placed your resume with 2 new agencies. This is getting hired. So this is just basically like, here, we've given your resume out to a couple companies, and hopefully you get something back. And then this one is follow up on that, being like, hey, here's a company called Untitled Electronics. They want to hire you. Hopefully you do that. And then the last thing is a visa application form for moving to the area. So, we live in China. That's the concept right now, and we are working in electrical engineering. So we're gonna get this first job here. All right, this product is an imitation mock security camera. It has 2 blinking lights. The first blinks in a regular pattern. The second light is an internet light, so it should be blinking in a more random, intermittent pattern to resemble data upload. As you will notice, the design is partially complete already. A previous engineer quit before finishing the assignment. Note the timing diagrams in the verification tab. When you simulate, your outputs should match those expected values as indicated. Let the simulation run until it has passed all of the test cases to make sure you have a proper solution. And then Carl says, I'm absolutely certain you'll do better than the last person. And so we're going to open up this CAD concept. There we are. Pretend CAD. Alright. I don't know how to use any of this yet. Okay, here we are. I'm going to switch back over to here so we have the little manual here. So, let's see. What are we working with here? We have fake surveillance camera. This is an MC4000. There are 2 types of pins on MC number microcontrollers, a simple I/O and an X bus. Note that they are not inoperable and can only be connected to another pin of the same type. Interoperable. Okay, they're not interoperable. Simple I/O values are continuous signal levels from 0 to 100. Inclusive, simple I/O pins are unmarked. Simple I/O is used for applications such as connecting a microcontroller to a simple input, such as a button, switch, or microphone, or a simple output, such as an LED, speaker, or a motor. Okay, so these are simple things. Okay, so how it's set up right now, we have the red light blinks. So we need to get it to do the other thing. We need the other light to intermittently blink. All right. So this is the information we need for this XBus. XBus values are discrete packet data packets from -99 to 999, negative 999 to 999, inclusive, including the negative 999 and 999. XBus pins are marked with a yellow dot. So these two are the XBus ones. These ones are the regular Simple I/O. Simple I/O pins can be read or written at any time with no regard to the state of connected devices. XBus, however, is a synchronized protocol. Data over XBus pins is only transferred when there is both a reader attempting to read and a writer attempting to write. If a read or write is attempted without a corresponding operation on a connected device, the operation will block. So basically, something has to be trying to take or give data, I think, in order for that one to function. I don't think we need it for this specific thing. What do we got here? Application note 393, get enough sleep. Okay, CPUs are typically much faster than the signals they are reading and writing. A CPU can execute a very large number of instructions within one time unit. To advance to the beginning of the next time unit, a CPU can go to sleep. To put a CPU to sleep, use the SLP instruction and specify the number of time units. Okay, so if we look at this code right here, I don't think I can edit that, but if you look at this code right here, it says SLP 6. That means it is going to sleep, which is basically turning on and off the light. So, we take one of these, connect it to that. We just copy this, paste that here. We should have two lights that do the same thing. Okay, we did that. We have two lights that do the same thing now. So now, let's see. I want to sleep 5, I think. Or do I want to sleep none? So 5, sleep 4. Sleep 4. Hopefully you can hear me properly. The mic is in a different position than normal. Hopefully I am audible. Sleep 4, not 45. Ah, shoot. I am... Sleep 4. 4. There we go. And now that should click on. So, okay. So basically what we're doing here is we're putting it into a state, telling it to stay in that state, and then putting it into another state. So, like this, we should get on, off. So, I want to copy this. So, on, off. I see. So it's off for 4, on for 2, off for 1, and then I want it to be on for 1. Something like that. On, off, on. There we go. Okay, I think that's it. We did it. All right, we'll just leave it. We got to leave it going. Nice. Costs $6, uses 60 power, and 12 lines of code. I'm sure that this can be done simpler, but I don't know how to. Based on my knowledge of this code so far, that's what I got. So, thanks for your prompt work on the blinking lights. Looks okay. Nice. Shenzhen days. Why are we here? Why are we even here? Hi everyone. We've had a bunch of new signups this week, so let me reintroduce myself. I'm your host, Tilly Liu, and I run this fun little mailing list for expats in Shenzhen. I think that's me. I'm here to demystify some aspects of life and culture here, along with a side helping of color commentary. Sometimes just the color commentary. Yeah, I get distracted. Today's topic is, why the heck are we here in Shenzhen? No, really. Like, why are we here at all? I don't mean in the immediate sense. Sure, we all have some job or some businessy thing to do, but let's talk about the larger factors at play. We are here because Shenzhen's been one of the fastest growing economies in the world for the past few decades. Ever since it was declared a special economic zone back in 1980. We're here because it, and really the entire Pearl River Delta region, is a small, sprawling megacity, wholly dedicated to trade, manufacturing, and services. A giant economic machine. We're here because what's possible in Shenzhen really isn't possible many other places in the world, certainly not at the same scale and cost. So, where's all this capability headed, in the future? Are we going to just make more stuff, more products and things until the world is buried in crap? I guess I'm asking, what is all this incredible growth for anyway? I have some ideas, but that's a topic for another day. Yours, Tilly. Okay, so there's Tilly. Let's go back here. Here's the Solitaire. I don't know much about the Solitaire. I bumped the camera, I don't even need to bother with it. It's not there. Okay, I don't know what the rules to this... Let's see what the instructions are. To win, stack the 3 suits from 1 to 9 in the top right corner. So there's 3 suits. Cards can be stacked and moved in the center of the table, but only if they are of alternating suits and decreasing values. The free cells in the top corner of the table can store 1 card of any type. 1. When all 4 dragons of a single type are exposed, they can be permanently moved to an open free cell by pushing the corresponding button. Okay. We have 1 of this suit here. I don't know what these cards mean yet. Ah, okay, so those are the dragons. Four, 3. Okay, I can move those collectively. I'm just gonna hit the new game button and see if I can... Okay, so we start at 1. We started 1. One. It's a dragon. Can I move these? Where did these move? So what do the dragons count as here? That's my question. Alright, I will mess around with that another time. So, back to work. Our factory floor has some examples of older equipment that require control signals to be amplified. We had a device to adjust signals for this type of machine, but recently it was broken, smashed. This is an appropriate project to teach you about inputs. GA. Carl says, smashed? Hang on a second, what happened? Is everyone okay? No need to worry. Okay, so we'll open this in CAD. Open design. Okay, so control in is a simple input connected to factory equipment. Control out is a simple output connected to other factory equipment. The signal from control in should be multiplied by 2 and copied to control out. Okay, so let's look at this. Programming language. Might as well put that full screen for now. So this is the stuff that I'm looking for in terms of the programming language. Let's see if I can find basic instructions. This is what I would like to look at. NOP, this instruction is no effect. MOVRI/R. Copy the value of the first operand into the second operand. Jump, sleep, SLX, sleep until data is available to be read on Xbox. Okay. Arithmetic. Okay, so multiply. This is what I'm gonna want here. I need to multiply the data by 2. So if I just plop this here. Alright, so pull the thing in here, multiply 2. You gotta tell it to sleep, obviously. But it doesn't output anything. So that's the current issue. Doesn't output anything. So I'm going to go back and look at this manual. Alright. The MC, whenever family of microcontrollers employs a programming system to simplify system design and reduce new product development time. A program written for one member of the MC XXXXX family can be reused in any other microcontroller with few or no changes. There's a note about that. Programs are assembled from a small number, a small but versatile set of operations. Each line of a program can contain an instruction, which consists of the instruction's name, followed by 0 or more instruction operands. Detailed descriptions of the available instructions and their usage are provided below. Microcontrollers are designed and used in power-constrained environments and applications, and program system has been designed accordingly. Microcontrollers in a sleep state, it consumes no power, otherwise power consumption is proportional to the number of instructions executed. Varying figures, pinouts, and program space limitations described in the model-specific datasheets. Some adaptation may be required. Okay, that's the note. Program structure. Each line must have a following structure. Label, condition, instruction, comment. All components are optional, but must appear in specified order if present. Examples of synaptically valid lines include line as comment, loop, okay. So what if coming back over to the game, what if what is it? MUL, the value of the first operand by the value of the ACC register. this do? Nothing. Any line of text following a number symbol is ignored until the end of the line. Comments improve developer productivity by allowing the behavior of code to be described in line with the program itself. Labels must appear first on a line where they are followed by a colon. Labels are jump targets. Okay. Conditional execution. All instructions in the programming language are capable of conditional execution, preferring an instruction with a plus or minus symbol. Let's pull this back up to here. Will cause that instruction to be enabled or disabled by test instructions. When an instruction is disabled by a test instruction, it will be skipped and will not consume power. Instructions with no prefix are never disabled and always execute normally. All conditional instructions start in a disabled state. A test instruction must never be executed to enable conditional instructions. For an example of conditional instructions, use a thing in the first section. Okay. Registers are for data manipulated. Set of registers. Okay, so this might be what I'm looking for. Okay, so we got examples of how to use multiply in here somewhere. Test instructions, okay. That is not as useful as I would have liked. And this is the microcontroller we're using here. A reduced functionality microcontroller to help lower BOM costs. The M4000 is this is the C4000, yep. Is a flexible and versatile alternative to its larger cousin, the MC6000. Okay. At any given time, a simple I/O pin is either input or output mode. Writing a value to a pin register will put the corresponding pin into the output mode. So I need to basically take the data, multiply it by 2, and then output it to the other thing, which should be obvious. So the question is now, how do I do that? Let's look at this example, which has code on it. Well, I mean, I guess we can look either, because I think this page also has code on it. This would have been helpful that's helpful for the last one. This one. Let's look at what we got here. That's not particularly helpful for me right now. I might want to use the X bus for this one. That might be the situation here. So let me flip back. So that is not correct. I do not want to use XBus. I tried. All right. Back to reading the manual. Registers are used as sources and destinations for data manipulated by the MC series instructions. The set of registers varies between models. It is an error to use a register in a microcontroller program that is if that register is not present on that microcontroller. So, I don't know how to do this in the code yet, but I want to basically take, if I click back over, I want to take P0 here, can see that, P0, multiply P0 by 2, and then output it through P1. That's what I want it to do in code. Got to figure out what code that I use first. So let's flip back to looking at the manual. ACC is the primary general purpose register used for internal computation on the MC family microcontrollers. All arithmetic operations implicitly use and modify the value of ACC. So I should just get that, I guess. DAT is the second register available. It can be used in most contexts where ACC is permitted. The internal registers are initialized to the value of 0. The pin registers P0, P1, X0, X1, X2, X3 are used when reading from or writing to the pins on the microcontrollers. Reading and writing through the pins allows a single microcontroller to communicate and coordinate with other connected compatible devices. Each pin on an MC family microcontroller functions as either a simple I/O or X-bus interface. Refer to the appropriate data sheet for details on pin functionality. Null is pseudo-register. Each type of instruction requires a fixed number of operands. If an instruction has any associated operands, they must appear following the instruction name, separated by spaces. For the benefit of development productivity, the MC programming system does not require the use of redundant punctuation to separate instruction operands. Instruction operands are described with the following notation. R is register, I is integer, R/I is register or integer, pin register is P, and label is L. So integer values must be in the range of -999 to 999. Labels used as operands must be defined elsewhere in the program. Alright. So, let me double check what X-bus pins are again. Is that over here? X-bus are discrete data packets from -999 to 999 inclusive. X-bus pins are marked with a yellow dot. X-bus is commonly used to transmit data between two microcontrollers or a microcontroller and a complex input or output. So this is a simple input or output, so not helpful here. Registers can store integer values. Okay, so I have the functions. Let's look at these example test instructions. For more information on the conditional execution, plus or minus, see conditional execution on page 2. TEQ, test if the value of the first operand is equal to the value of the second operand. Okay. TGT, test if the first, okay. Test if, these are comparative. So these aren't what I want either. All right. So let's start this code over. Go back and look at some of these reference ones to get some ideas. All right, what is MOV? Ah, there it is. Copy the value of the first operand into the second operand. That what I want? So I do I am still missing something here. Okay. So, I'm almost there. There's one piece of information that I need to find. So, okay, so how do I put the pin register? I got it, I think. Is this it? Yeah! Okay, I think that's it. I think we got it. Alright, it took some doing. It took some figuring out. I have a little bit of, like, coding experience, but this is its, like, own language, so I don't know what I'm doing. I'm learning this on the fly. Alright, I'm sure, you can get some better power usage, but I did it. Got it. Cool. Alright, we have please enjoy a game. Alright, my daughter is learning programming. Let's do that. My daughter is learning programming. She's created a simple card game. Would anyone like to try it and give some feedback for her? I put a link on everyone's desktop. Okay, that's the Solitaire. She's interested to become a game developer. Wow, Jay, that is a lot more polished and far harder than I was expecting. Your daughter's managed to design quite the challenging patience game. Maybe there could be an undo function. She says she doesn't think it needs an undo because it's actually quite easy once you develop some skill. She really takes after you. Alright, so now our main objective is Solitaire. Nope, I don't know what I can put 9s on. Am I able to put... I forgot I can hold cards in this spot. Okay. I'm not stupid. I'm only a little stupid. Alright. I don't know if I can... Okay. Try again. Give me a new shuffle. Those are all the same color. Okay. All right. That is helpful. How helpful is the question? Is there an open 6 somewhere? No. There's an open 5 though. Now there's an open 6. Shoot. That was a mistake. I'll put that... Okay. I think I'm stuck again. Okay. New game. Solitaire. We can do this. This is the whole reason I bought this game. Where are the 3s? The 3s are all under stuff. That's not good. And the red 2... The one that's there. Okay. Do I have a 7? don't have an open spot. That sucks. Alright, starting over. That's probably a bad idea, but that's what I'm going with this time. Shoot. That's the same color. This is not, can I do that? No? One more round of the RNG bingo. Okay, what do we got here? So, where is the other, this? All right. One down already. Okay. I'm uncovering greens. That's my goal here. There's a 3. 1, 2, okay. All right, we did that. We've done that. Okay. Ooh, okay. Okay. 6, 9. Did we do it? Yeah! Solitaire! Woo! I got an achievement for that. Alright, we did it. We won a game of Solitaire. This was work. This was our work for the day. Can't read that. Incapable of reading that. Anyway, all the parts. We're going to try one more, and then I'll probably have to be done, because we're approaching on an hour, but I've spent a lot of time reading a manual and stuff, so, and not talking that much, so we're going to do another job, and then we're going to call it quits for this episode. Now that you're up and running, I figure it's safe to let you use all the lovely parts we have available to us. Just be warned that not all of them are going to be useful for what you are doing immediately. On you go then. Okay. Pulse generator, a diagnostic pulse generator, create a working design for this product to view histograms and leaderboards. Okay. In order to test some of our new manufacturing equipment, we need a pulse generator with certain requirements, specifications. However, instead of buying one at market price, I thought we could create our own. For this project, you will need to make use of conditional execution. Please study Please continue your study of the language reference. GA. Alright. Let's do that. So here we are, again, making a diagnostic pulse generator. Button is a simple input, so we're doing simple inputs again. Pulse is a simple output. When the button is pushed, generate pulses as indicated in the verification tab until the button is released. That should be... okay. So I want to take P1 into ACC, I assume. Okay, so I'm going to use the MC4000. I'm not... There's a bunch of other parts here, but I'm going to use the MC 4000. I think I could do it with this. So basically just want it onto sleep 2, onto sleep 2. I need to go back and look at V0. What does this look like? No. It looks like no. Okay. So that is almost what I want. So now I need to figure out the conditional statements part. Let's do that first. And by first, I mean second, because I've already... Conditional statements. Alright, so let's go back into to big here on the manual. All instructions in the MC programming language are capable of conditional execution. Prefixing an instruction with a plus or minus symbol will cause that instruction to be enabled or disabled by test instructions. When an instruction is disabled by a test instruction, it will be skipped and not consume power. Instructions with no prefix are never disabled and always execute normally. All conditional instructions start in a disabled state. Test instruction must be executed to enable conditional instructions, and then I'm going to want to look at this page. So TEQ is test if the value of the first operand is equal to the value of the second operand. The button is already programmed. So basically in this situation, button, this is telling the button to button. So, okay, so now, let's look at this. Look at this there. This is what I got here. MOV 100 ACC means ACC is the value 100. So then we are testing if P0, the input, is equal to ACC, which it will be. And then, if it is, we're going to output 100 to P1, and then sleep 1. If not, the value is 0. So, if I hit this button, it should just work properly. Yeah! We did it! I don't know what these graphs mean for me. Yes, looks okay, suitable for our purpose. Woo! We did it! We have done 3 electrical engineering coding things today. That is probably enough for today. So, I said 3. We did do 3. We also played Solitaire. So, we did it. So that's that's the video. This was a bit of a mess because I've not really recorded with Discord as setup before, so still figuring things out. But I think that was cool. If that, hopefully you thought that was cool. So I'm gonna maybe do more of this. So yeah, stick around. So like the video, if you liked it, whatever. The description, links, subscribe, comment, share, do the things. And thank you so much for watching. I'll see you next time. Bye!